Why should travel to the space? Well, there are too many reasons to travel to the space, maybe scientific or military or communication, and there are different ways to travel to the space. One of them it is unmanned aircraft or flight, and another one that is manned flight. One example of those unmanned flights is like a Curiosity, that is a NASA Mars exploration program to study Mars as a planetary system in order to understand the formation, the evolution, the history of the geological and climate processes. Okay, so the future of exploration maybe of Mars by humans. Now, we have also manned flights as the Crew Dragon capsule that was detached from ISS last Saturday. So, Crew Dragon was built up by SpaceX, which owner is Elon Musk, who is a physicist and also owner of Tesla and Hyperloop, and it was the owner of PayPal. So the idea of this space travel is to prove how convenient are the travel to the space for those people who can pay for that. Even though it is amazing that a human being can go out of the earth, okay? But how this topic is related with our class? Well, the first thing that we have to know is about forces. Okay, so what is force? Force is any push or pull upon an object resulting from the object's interaction with another object. So, wherever there is an interaction between two objects, there is a force upon each of the objects. So, there are two types of forces, like contact forces or action at a distance forces. Okay, so what it means contact forces are those type of forces that result when two interactive objects are perceived to be physical contacted each other. So an example of these type of force is like air friction or air resistance, normal forces, friction forces. So that's the way that contact forces act. Now, action at a distance forces are those type of forces that results even when the two interacted objects are not physical contact with each other. So they are able to exert push or pull despite their physical separation. So an example of this, gravity. Gravity between the planets. You know that gravity is like a deform of the space-time. So it depends on the mass. So the mass is going to affect other planets and that stuff. So gravity is a good example. Electrical force between the charges, between electrons and protons and neutrons. So magnetic forces, that is stuff that our planets have to avoid the magnetic field of the sun. So that's another type of force. So what is going to be our unit for forces? We are going to have Newton. Newton is just like a standard metric unit. So 1 Newton is the amount of force required to give 1 kilogram mass acceleration of 1 meter per second. So we are going to have Newton as a unit. So also force is a vector quantity that has both magnitude and direction. It has a number and it has a direction. So because force is a vector that has direction, it is common to represent forces using diagrams in which a force is represented by an arrow. So that thing that you can see here, arrows. So for example, you can represent with arrows the tension by a rope, okay, over here. the weight of a car when it is climbing a inclined plane. For example, over here we have this system, so you can represent with arrows the normal force, for example, and in this case too. So with this free body diagram, you can represent all the forces that are acting on a body. Okay? Now, we are going to find four elemental forces of the nature, four fundamental forces. So, we are going to have the first one, gravitational or force due to the gravity. So, it's the interaction between the objects that have mass or energy. So, as I told you, the simple example of this is our planet exerting a gravity force, okay, gravitational force. The other one is the weak force or weak nuclear force that is responsible for the particles decay. So this is literally the change of one type of subatomic particle into another type of a particle, okay? So the next one is the electromagnetic force that acts between charged particles, protons, electrons, or neutrons, that what we find in an atom, okay? So that's the also the way that our electromagnetic field acts on the earth, okay? And the last one and the strongest one is a strong nuclear force. That is the strongest of the four fundamental forces of the nature, and that's because it binds the fundamental particles together. So this is the reason why protons keep with and neutrons keep in the atom's nucleus, and they are together. So the strong nuclear is the reason why the atom has a nucleus with protons and with neutrons. Okay, Albert Einstein spent almost like 30 years of his life chasing after like the greatest unification of all the theory of those all the forces, all four forces, trying to do just one equation of this, and it was called theory of everything. So he felt frustrated because he couldn't get that equation to explain everything and to read the mind of God. So that's the important part of those four fundamental forces.